Hello, ladies and gentlemen, and welcome back to Calculus with Trump. Today we are doing applications of integration, specifically average values and mean value theorem. So let's get right into this. Now, number 2 question on the study guide tells us that we need to find the average value of f on the specific interval and find the number c that satisfies the conclusion of MVT for the integrals given this specific integral. This is very good. This actually is a very simple problem that is pretty easy, and I would be very happy to see on any exam, including AP. So first things first, we need to find the average value. Now they give me the function, which means I need to integrate that function and multiply it by my interval. Let's make my integral. First things first, they've told me, first of all, the interval that my integral's on from 0 to 2, which means I can do my upper bound being 2 and my lower bound being 0. And they've also given me my specific function to use, which means I can now use and plug in 2x squared plus 3. Now this gives me my integral, and I could solve this to find the area of my integral in the function. But that's not what they're asking. They're asking for the average value, which means we need to multiply this by usually some form of a fraction. In this specific question, it is on a area, the average value of f on 0 to 2, which is the same thing as our bounds. So now we need to create, just like on question 1, if you haven't seen, you would probably look on the other video because we explained averages very well. I'm not going to go into as deep. Which means we can now make 1 over, and remember, 1 is just our value, because we are going on an interval, and we aren't changing this value, it's just 1, because they haven't explicitly told me anything else. And if they haven't explicitly told me anything, I'm keeping it with 1. And I'm going to take the high value, 2, and minus it from the low value, which is going to give me 1 over 2. Which all this does here is this is going to give me my average value instead of just the area. Now, throwing this into a calculator, because I'm too lazy to solve it, is actually going to give me 5.67. Or you could also say, which is probably how you're going to have to do it if you don't get a calculator, 17 over 3. So let's put 17 over 3 here. And we've found our average value. But that's not it. That's only the first part. We now need to solve the second part. What does C equal? Oh my god. Now, in order to solve the second part of our question, we need to have solved the first problem, which we have successfully, 17 over 3. And what we now do is we take our function and we plug in here 2x squared plus 3, oopsies, plus 3 equals a specific value. But I'm actually going to replace, what I'm going to do is I'm actually going to replace the x with c squared instead. So I'm just going to replace the x with the c instead, and that's just a different value because I've asked specifically for c. Plus 3 equals the value that we have found previously, our average value, which is 17 over 3. Wonderful. Now, if you don't understand exactly why we use c, it's because we are solving for specifically average value, and if we solved for x instead, that would be wrong, because x is for the actual value of the equation, the actual area, and the actual perimeter of the entire function. But c is solving specifically for mean value theorem, for the mean, for the average area. It is solving for a different, area than the regular integral is. So we replace it with c so that it's specifically a different variable. But now let's solve for t. See, now at this point, it is just basic algebra. So this is very easy. We can need to minus 3 on this side. And in order to minus 3 on this side, we need to minus 3 off of this value. Now, minusing off of fractions is very easy because we multiply 3 by 3 in order to give us our function. Now, 3 to minus it on this side, in order to minus 3, we're just going to put it over 3 so that we have a common denominator. So what we'll do is we'll put it over 3. But if it's over 3, we need to multiply it by 3 so that we get 9. Why? Because 9 over 3 is equivalent to 3. I hope you understand that. Please tell me you do. Now what we do is we minus that off, and that gives us a very fun value of 8 over 3. Oh, pardon me. 8 over 3. Silence! 8 over 3. Now what we do is we divide by 2. Very easy. It's very nice. Now when you divide a fraction by 2, all you do is multiply your denominator by the value that you've divided it by. So it means 8 divided by 3 divided by 2 just becomes 8 divided by 6. And then we have c squared equals 8 over 6. 8 over 6 divided, and then you have to square root the values in order to get it even, Steven. And we can also, sorry, before we do that, actually, sorry, I'm jumping the gun here a bit. What we really want to do is we want to actually also simplify this at the same time, so we don't have as complicated as a fraction. And 8 over 6 is equivalent to 4 over 3. That's important so that our answer is fully simplified, specifically on if you have an MCQ. Now, technically, this is a short response, which means I could have plugged in basically any value it wanted because I get to respond, and any value, including this, would have been true, but I need to solve for C, so to keep it simplified, and so it's a small, nice number, we're gonna do this, because why not? Which means it's actually just equal to 4 over 3. And when we square root, and that is our final answer, because C equals the square root of 4 over 3. But this actually can be simplified just a little bit more, because 4 is actually a perfect square root, so we can do 2 over the square root of 3, because 2 can come out of the root, because it is a perfect square. So now we can just do our final answer of 2 over the square root of 3. But this is also equivalent to the value of the square root of 4 over 3. But if you're solving an MCQ, they might make you simplify it fully. Anyways, I hope you guys enjoyed this calculus problem. Bye-bye.